All right, here we go. All right, crinkle, crinkle. Okay, told you it's one of my favorite things. I love algebra and balancing equations. A nerd when it comes to that. And then, oh, guess what? We're gonna solve trig equations today. What? There's no sinners in this public school, right? What does that stand for? Sine. We did do that last year. What's x equal? 3, 2, 1, go. It's got to be 7, right? Just by default, you just solve the trig equation. Isn't that fun? Okay. What's another one we could solve? Oh, what's this stand for? What's LO6? I don't understand. Does anyone know what that stands for? Not logistics. I do like that though. Good guess. There's a thing called logarithms that's coming up. Oh no, that was last hour. Logarithms are another form of exponents. What's x equal? 3, 2, 1, go. 12. So it's just by default, if log of this equals log of that, well, then this has to equal that. I don't even know what a logarithm is. I don't even know how the sine function works in an equation. But I at least know if I replace x with 7, then these two sides are exactly the same looking. So it has to be balanced, right? Right? So this is just a common sense, this is not like I guess it is I don't know if it's a equation. I'm really making a fool of myself right now on the internet. Nobody watches anyway. I mean, come on. But I just was thinking of it, is it some sort of equation attribute or whatever? Not a formula. I'm trying to think of a word that's mathematical. I'll just shut up for a second and think about it for a while. So what's 64? A number. Can you write that in terms of 2? What is 64? 2 to the what? Sixth is right. That's a numeric person over there. 2 to the fourth is 16, and then multiply by 2 more times. 2 times 16, 32. 2 times. So I'm going to tell you right now when you need a logarithm. When you cannot do this. When you cannot do this, then I need a logarithm in order to make the equation solvable. So understand that right away. So we will not have questions where the bases cannot be written as equal. That was a double negative. I know that. So a couple bad English things here today. Couldn't think of what I was thinking about for equations, and then a double negative there. So where did the twos go? I dropped them. Where did the signs go? I kind of dropped them because it just is. If sine of this equals sine of that, then this equals that. If log of this equals log of that, then this equals that. If 2 to this power equals 2 to that power, then this power equals that power. It's the same concept. It's balance. And then 2x equals -4, x equals -2. Everyone okay? Input, say it. I could throw that in. 2 to the negative or 2 times -2, sorry, is -4. -4 plus 10 is 6. 2 to the 6, we just proved is 64. So it works. All right. What's the common base between 8 and a half? What is it yet again, everybody? 2. Don't try to make this in terms of 8s. Try to find the smaller, but this is what people do wrong. To write that in terms of 8, you would need like a cubed roots, right? Isn't the cubed root of 8 2? And then you have to write, that's harder. Just make this in terms of 2 and make that in terms of 2. And you must replace these with equivalent ideas. I was about to say expressions, but I guess it could work as one side of the equation. And then what's 2 or what's 1/2? 2 to the what? 3, 2, 1, go. -1. Last hour didn't say a word. And then did I go over that too fast over here? No, there's really nothing to do on this one. What do I do with these exponents? That's what I was looking for. What do I do with those exponents then? Multiply. And then what do I do with these exponents? Multiply. So we multiply and then maybe drop the 2's at the same time because it's true. Just a simple basic idea of solving. Yes, okay. So add 2x to both sides, I get 5x. Add 3, we're in honors, 4. Swear to dog, man, I get AB students just, man, this class is so hard, and they just, because they can't do these things. Like, they're, wait, how'd you get that 4? Okay, I know, it's just the basics that they came in from other classes. Thanks for listening yet again. I'm going to do this one more time. We're going to show this on the calculator how you can check this. Really don't think this is a bad thing to do. Okay, I'm going to clear and start fresh, and then I got to move this over to this side. I got to do this over here, otherwise the computer gets all wonky. I hate that thing. I got to turn that off somehow. All right, so how do I check this answer? Well, first of all, I got to put in 4/5. Wrong. Enter store X. I got to store it in for X. Then I type in these expressions. I've showed you this before, right? All right, so 8 carrots, delicious. X minus 1. Enter. What the heck does that mean? Well, let's check the other side. That's what it means. And I better do this. 1 divided by 2. If I don't use the fraction button, you better put it in parentheses. Otherwise, it might only take the 2 to the power, which actually would be okay because the 1 is the numerator. But that's beside the point. Smart to make the whole fraction in parentheses. Caret, and then 2x minus 1. You'd be a lot faster than me on this if you had a graphing calculator. That's what that means. That means when I put in 4/5, the equation's balanced. I get the same thing on both sides. So anyway, I've showed that before, I believe. Just thought it'd be a good moment to do that. What's the common base between 216 and 36? 6. What's 216? 6 to the third. Negative 4x plus 7. And then this is 6 squared. 2x plus 1. And then what do you do with these? You multiply. You already know. Negative 12x plus 21. We won't do any more checking on the calculator. Is a fat or a mac? Are you okay with this? Do you need me to solve a two-step equation? Can I move on? Right? I don't need to do that. Come on. Who are we? We're in honors here. We don't need to keep seeing two-step equations being solved. All right, this gets a little bit bigger. This just requires some rules. What's the common base, though? Simple. 3. So this is equal to 3 squared. Equivalence. And then this is just 3 to the negative x. No change needed. That's it. Sorry. I don't know what I'm doing. Equals. And then this is 3 to the third raised to the negative 2x minus 1. Okay, first things first. What do I do with these exponents? What do I do with those two? Multiply. But then what do I do with these exponents? The green. Add. So I'm going to put a green add here because I'm going to drop the 3's now after I do this. Multiply these two exponents, which this becomes negative 6x plus 2 times 2, 4, and then add that to this negative x. Okay, so that's why I was trying to do the two rules at once. We're in honors, we should be able to handle these multi-step, things. And then this is negative 6x minus 3. Do you need me to solve this, or do you know how to solve a 3-step solving basic grade school equation, right? Next one. Oh, no big thing. What's the common base here? This is tough. What's the common base? E. So this is e to the 5x. And then this equals ex squared times e to the what, everyone? 3, 2, 1, go. Some people are waiting for the 3, 2, 1. Okay, and then what do you do with those exponents? Add them. So this is 5x. I don't know why I was throwing a negative there. And then x squared minus 14. You do add those exponents, then you drop the e's. The step that I have someone giving me like weird eyes over there. The step I'm skipping is writing this one. You take these exponents and add them. And now e to this power equals e to that power. The powers equal. You drop the e's because sine of x equals sine of whatever, x equals whatever. Log of x equals log of whatever, x equals whatever. E to this power equals e to that power, only if this power equals that power. And then good FOILers, anyone? Here it comes again. Remember we had geometry last year? But then in every geometry section, we added sides to the geometry figures that required factoring to solve. So we get factoring involved in exponentials. Now, you can check these answers if you had time. You might think, could there be extraneous solutions? I didn't have to square both sides. That happened when we were solving parabola or polynomial equations. But if it would make you feel better, -2 times 5 is -10, so e to the -10. -2 squared is 4. So e to the 4th times e to the -14, add those exponents that you get -10. It works. So worried about that negative, you can do the same thing with the 7, and it does work. 7 squared is 49. Add -14 to 49, and you do get 7 times 5, 35. So you do get those equal exponents. Then one more time of me not finishing. Isn't this exactly like this one? Isn't it? I didn't even do this one last hour. What's the common base? 5. And then, something crazy is going to happen. It's going to be a combination of algebra that from the old times, some sort of quadratic that we're done with, but it's the same idea, right? Can I move on? I think we know how to factor. I'm going to be totally honest. I got to this one and I thought, when I looked at the notes real quick, I go, yeah, I know how to solve this. At first, I was like, wait, this is a weird question. Oh, I got it. All I have to do is find x, solve for it, and then input, say it. Put it in there, and then it's 5 to the 3 times that answer. But then I realized that these bases cannot be written equally. So what I had in my mind is I know how to solve this, and I know how to solve this using logarithms. But I just realized you've never heard of the word logarithm. Some of you, right? You don't even know what it is. And all a logarithm is writing exponents in a different format so that you can solve for exponential equations where the bases are not equal. So then, awkwardly in 4th hour, I'm like, whoa, I actually don't know what to do then. Actually, I thought I knew, how to teach this to you, but I forgot you don't know something. So then I kind of struggled, and then I'm like, you know what? Here's what I could do. Whatever you do to one side, say it. I'm going to turn this into 5 to the 3x by whatever I do to one side, I do to the other. Like the first thing, whatever I do to one side, I do to the other. Let's raise this to the negative first power. What does that do to these two exponents? What happens? What does that become? 5 to the x. And then you know what I'm going to do next? I'm going to cube this side. Why? Because I'm just trying to get this to happen. I'm trying to get it to be 5 to the 3x. So I'm using exponent rules in order to get, satisfy this crazy question. So what's 5 to the 3x power? 1 over 27, right? Isn't 3 to the negative third, 1 over 3 to the third? 3 times 3 is 9, 3 times 9 is 27. So that was kind of fun. I mean, I'm not embarrassed by it about not knowing what to do. It's just kind of an outside the box kind of question. And I had to think on my feet last hour, which is what a student in honor should be able to do too. Not that you would be able to figure it out, but I bet you some of you would have been able to think like I did. Okay, well now this becomes, I'm going to do it all at once then. So what do I have to do to get this to turn into 2 to the x? I'm giving myself some space. And by the way, isn't this 10 to the negative third? That might be nice, right? Right? You don't have to do that. I just thought it'd be a better getting ready thing. So how do I get rid of that negative? I have to raise both sides to what? Negative first, right? And then how do I get rid of that 3? What can I do to get rid of 2 to the third? Get rid of the third power. What's the opposite operation of third power? Cube root, or, oh, sorry, I didn't do whatever I do to one side, I do to the other. Whoops. And then the other side, I'd have to raise to a 1/3 power, which is the same as cube rooting. And now what ends up happening is a negative times a negative is a positive, and then 1/3 of 3 is 1. Three's in my head. Okay, so 2 to the x is what results, which is what I wanted. What does 2 to the x equal? Hey, 10, right? Right? Same thing happens on the other side. So the answer is 10. All right, next. Big yawns. Me too. I had a panini. Did you guys smell onions when you came in? No? Kind of went away? All right. 4th hour, I smelled the onions in my sandwich. Supposed to be reading. By the way, input, say it. That's all we can do with these right now. That's all these questions are, input outputs. Kind of a weird equation. This is an equation for the size of the wound on your body. Ugh. Okay. Then if there is no infection, what happens with an infection? Sometimes the wound grows or never heals. It gets worse or grows, like because there's a bacteria in there and then it spreads. But if there is no infection, it should shrink. All right. And then so look at that. That's weird too. We got E involved in that, right? Again, the natural processes in life and in money and whatever, E, that magic number comes about. It's really, really, really weird. Cool number. So what is A sub 0? The starts with an I. IN. Oh yeah. All right. Yeah, initial amount is that what is the initial amount? What is the initial area? And then actually I'm input outputting, so it's 100. You don't need me for, well, okay, fine. I'll go to the calculator one more time. Sorry, that's a 3, 5, and then 3 goes here. Just real quick, where is E on your calculator one more time? It is in 2 spots, but this one doesn't have a caret on it, so it is above division. The better one is the ln button, which ln is just natural logarithm. Another yawn back there. Holy smokes. All right, so wrong. All right, 100, hundo. You don't even need the times button. Second ln, it's all red right there. So find your own button there. If you have a scientific, there's an E button on the scientific as well. Sorry. Caret negative 0.35 times what? 4? 3? And then just press enter. It's getting smaller, right? That's the idea there. And then the same thing for this one, just input, output. I think the other class I did the second one. 100 E negative 0.35, 10. And I just inputted that one. And then what's the price P in dollars of a Mac laptop that is X years old? Modeled by this. What's the 1450 represent? Anyone? This is about true, by the way. The initial price. I don't know what they are now. I think they might be very similar. Those are still pricey computers if anyone's buying them anymore. I'm kind of in need of a new desktop. I kind of do like having a desktop. How many people have a desktop computer still in their house, like plugged into the wall and wired to the internet? I still kind of like those. Mine's getting pretty old. What's the 0.85 represent? Tell me this in terms of loss of value. This is going to be something that's important later anyway. How much value does this lose? It's in years, so per year. 3, 2, 1, go. Yeah, so this loses. Very well done. You're going to need to know this in this way. So the 0.85 means you lose 15% of value per year. You're going to need to know that. You're going to need to know it in that way per year. You retain 85% of its value. That means you lose 15%. You're going to want to express it in terms of loss. All right, and then input, say it's, I mean, this is really, you just put 4 in for there. What's 18 months? What's x equal then? 1.5. Is that it? I think that's good enough, right? I do like this stuff though, and I really love logs. Logs are fun. Can't wait to do those. But they're a ways away. It's because of AP, which is not bad. It's just other things are going to pop up.